Hello, Jason here with BC Edge. Today I'm going to be working on the tombstone for my fourth axis. If you're not familiar with what a tombstone is, it essentially is a rectangular or square piece of metal that attaches to the fourth axis, and it allows you to attach fixtures to it, and then when the fourth axis turns, it makes ready a new pallet. Makes things a lot easier to set up just one time and let the machine run. This one that I have here is unfinished and it has a few issues, so we're going to be remaking some pieces and I'll explain all that. This tombstone is one that I started building before I actually got the MicroARC, and there's a few problems. This is oversized, so I've still got plenty of material to take off of it. It's basically just been squared up. The adapter plate, which is this piece here, I used the model that Tormach has on their website, and the actual MicroARC doesn't match. The inside diameter here that helps locate is different, and so is the bolt pattern. So I'm gonna have to redesign that and start building a new adapter plate. So this is the design that I have set up for the tombstone. It's what I would call a mini tombstone. It's only 6 inches long from one end to the other. The issue that I had with the model that's represented here, you can see how far off those model designed holes are from the actual ones. So it's a pretty big difference there. It'd be nice if they updated their model. I'm not sure whether they still have it this way. Just remember that if you're going to be making one of these things, designing one, that this model that they provide isn't correct. This outside diameter actually is accurate. It's correct, and as well as the height of everything. All the external dimensions seem to be accurate. It's just this faceplate. Now I'll switch to the wireframe. You can see how this is all put together. I've got a few shoulder bolts holding the adapter plate to the tombstone, and so that'll help keep everything aligned and secure. The tombstone itself has these holes that are for some other shoulder bolts that will hold on the pallets. This is a 3.5 inch tombstone. That'll give clearance for when this is mounted directly to the machine table. When it rotates, it needs to have a certain amount of clearance before it will hit the table, which is shown here with this large circle. So that's how much room I have to put pallets on top or on the sides. Should be plenty for the small parts that I'm going to be doing. I've also designed a low profile tailstock. I don't know if I will actually need this or not, but I've got it designed anyway, just in case. If this has enough deflection when we put it in the machine, I'll definitely need to put this on so that this stays nice and solid while it's machining. You can see how this will work while it's on the machine. As I do one pallet, it can be used as a positioner to move it to the next one, then to the next one, then to the next one. And also, if I get a little more advanced with some things, I can tilt it so that with some of the end mills that come straight down, I can machine parts at an angle. I'll try that at some point, but probably at first, just use it as a positioner to get pallets lined up. So one of the reasons I designed this tailstock to be low profile is there's a limited amount of space in the machine. So this plus that plus the tailstock, all that takes up space, real estate on the table. And a normal tailstock, you can see, a normal one would look more like this. And you see how much more space that takes up. It's a good extra 6 inches that you can use in the machine. So with this low profile one, that will allow me to keep the vise a little bit closer on this and be able to utilize all that space in the machine, since I want to have that and the tombstone in at the same time. Alright, so let's start building this piece here, the adapter plate. It's going to take quite a bit of machining, and we'll have to flip it. That'll get a little interesting.
And take this apart and show you what the problem is on the machine. So it should mount on this face plate, and as you can see, this lip right here should match up with the inside of this, but it's actually quite a bit smaller than what the model shows. So luckily we do have two of the holes in here that are directly opposed from each other, so I was able to put some gauge pins in there and then measure with some calipers across this distance and then subtract the diameter of one of the gauge pins. So I was able to get the whole spacing that way, otherwise this would have been way more difficult. So I've got my piece of stock here. It's just a rough cut piece of 4-inch 6061 T6 aluminum, and in order to hold it in the machine, you can't just put it in the vise and tighten it down. There's not enough to secure it because it's a round part. So we've got some special jaws to be able to do that, to hold it in the correct way. So let me put those on and I'll show you how that works. Alright, so I've got these jaws in place. Now these are really cool. They're from Mighty Bite, and they're specifically designed for holding round stock. So the way that these work is they have these little clamps that have these teeth that when you clamp it down into the vise, it just uses those teeth to dig into the material. And that holds it really secure without taking up a lot of space, so you can machine a lot of the material. Now with this particular one, you could use it to hold one large piece of round stock, or you could use it to hold multiple pieces. Because it's 8-inch version, they make a 6-inch as well, but you could use this to hold several parts all in one setup. I'm just going to do the one. Alright, so you leave these a little bit loose so that they can rotate while you get it in place. And just when they touch, they're lined up, you can snug them down. Okay, then we can tighten it down the rest of the way. It will leave some teeth marks in your material, so keep that in mind. In this case it's fine because I'm going to be machining off a certain amount of that after. The other thing that's neat about these is that because the teeth are angled, there's no need to tap this down like you would a square part with some parallels. It pulls it down as you tighten it together. This part's going to require a few different tools. We've got a couple drills. One is a 1/4-inch 27/64 drill. We've got a long 1/4-inch 3-flute carbide end mill, a 3/8 normal length 3-flute end mill. And then we've got our chamfer and spotting drill. And then we've got a 1/8-inch 3-flute end mill that I have in a little extension that I made that actually works pretty well. That just helps give it a little more reach. I'm going to start by machining this top side, or what I call the front. It'll be machining off all this top material and then these cutouts and doing all the holes. And I have my Z0 set for the bottom of the stock, so I can just use the top of the jaws, touch those for the 0. And then it's the center of the round stock, so I'll have to probe that too. This is another special program for doing round stock in the controller. And that was this program right here, the Find Circular Boss Center, Find Center X and Y. So that's what it just did. Unfortunately, the camera battery died here, so we missed part of the main machining. I'm using this 3/8 end mill here as a reamer, and it's not the best way to do it. It really makes these long stringy chips that just make what they call a bird's nest, so I have to kind of take those off every time it does one, but it makes really nice clean holes. Alright, there's our part. Looks pretty. Got the top side all done. Made a big mess in here. Just how I like it. It's a good finish on that. This part on the outside is just roughed in. There's still some material that needs to be taken off of that. So this is just a rough surface. Got these facets on it. Smooth. Real smooth. Alright. Let's get this thing flipped over. I have to do a sort of a special fixture for that. Because of how this is set up, I have to make sure it's aligned properly when I flip it over. so that these holes are in the right place. Here's my fixture plate. I machined this off camera, sorry. This is just a piece of steel that I made flat, or attempted to make flat as I can. And I reamed a couple of 3/8 holes in it, and a hole in the center for the zeroing, and then some tapped holes for some clamps. I'll show you how this will work. So I need to be able to machine the back side of this and bore out some holes that are in the same locations as the holes that are already there. And so I can't just put it in how I did before, because it could be clocked in any position. So I need to be able to precisely locate this clocking. In order to do that, I have these pins that I made that are just some ends of some old broken end mills, and they fit into these little bored holes exactly. And what that will do is, when I flip this over, I've got my little spot there that tells me which direction I want to have facing the back of the machine. But lining those pins up with these holes will put it in exactly the right place.
So we lost some sound here for some reason, but just putting that down into the pins, and it doesn't rotate. So I've got to put the clamps on to hold it. So the way these clamps work is they have an eccentric cam that makes it advance when you turn it. So that'll hold it down. And I'm just tightening those all down. That should hold it in place pretty well. They don't really do much for holding the material in the holding the material downward, but as long as I tap it down, they should hold it in place well enough. Upon further review and taking some measurements of this plate, I found out that it was not completely flat by 2 or 3 thousandths in a few spots. So I decided to go ahead and machine the face of it just to make sure that it's all the way flat when I put the part on. Alright, so now we got it machined. It took about 3 thousandths off of it, and it's nice and smooth now. Should be just as flat as it can be.
one of the ways that you can tell how good your setup was is by the chamfers. Now, because I did all these holes and this bore, the center bore, in the machine while it was set up this way, and I did the chamfers on this side on those same features while it was set up in the other orientation. You see how even the chamfer is all the way across. Gives you a good idea of how close you got to orienting it correctly. And it's the same thing with these chamfers on those 3 other holes. They're basically perfect. I can't really detect by eye any mismatch at all. So that's a good sign. So we'll get this put into the lathe and finish off the machining there. Alright, so here we are at the lathe. I've got this arbor set up that I'm going to use to put the center bore into, because this is a little bit bigger piece than my tiny lathe. Have to use that to hold it, but got it running nice and true. There's about less than half a thou of run out, probably more like 2 or 3/10 to this inside lip, this inside diameter, and the outside. Just snug that down a little bit. Nothing too crazy. Okay, so I'm just going to turn that and get those diameters dialed in. I've got my boring bar set up here, and I'm just going to paint this with a little bit of Sharpie so that I can see what I'm taking off. I've only got about 4/1000ths to take off of this inside bore, so that's basically nothing. It's just like a skim cut. So you can see it cleaned up some on one side of it, and I'm gonna go ahead and measure that and see what we got. Okay, still got 2 thou more to go. You can see the Sharpie mark's almost gone there. That's the number I'm looking for. It's about 1 thou bigger than the boss on the Tombstone face. Should be a nice fit. Alright, I'm just going to do this outside bore. One of the things that I didn't mention before is part of the reason these facets are here and they're not on this side is because on this part, when I was doing these other pockets, I was just using an adaptive strategy on the toolpath. And an adaptive strategy is a roughing, and it doesn't make smooth corners. So that's why they did there. On this one I did a contour toolpath, and that makes a nice smooth circle. But we're going to clean all that off. I should have about 6 thou to take off of that. so that piece is all turned down. Got the inside bore already. A little bit of chatter in there, but it's to size and it's concentric to the outside, so, and to the bore in the center. So that's all I care about. And of course, the ultimate test is whether it fits on the thing that I want it to fit on. Oh yeah, man, that is a perfect fit. There is no movement at all. It just goes on there really nice. Man, okay, looking good. Need to check the parallelism on the surface plate, but that is just a perfect fit. Good. So we're over here on the surface plate, and what I'm going to do, I'm going to use this to measure the parallelism between this face and this face. Now this is important because the more, any error that you have here will translate and be amplified the further you go out. I've got my indicator. This is a 1/10 indicator with on a height gauge that I'm going to use to sweep across, and it'll tell me the relative difference in height at different points. Get a closer look at that. Yeah, so we've got a spot here that's a little bit higher than the rest of it. But that is less than 1/2 a thousandths difference across the entire piece. I'd like it to be better, but it's not bad. Yep, about 4/10 difference at the max. I think we can work with that. So that's going to be it for this video. I think it's probably been long enough. We'll pick back up on this later, so I'll see you on the next video.